In order for us to graph this by hand, we want to identify what's the parent function here. So the parent function here is going to be y equals, or g of x equals, however you choose to write it, 2 raised to the x power. Now let's go ahead and let's identify, remember we have no restrictions what we can plug in for the input values or x values. So let's go ahead and let's do a few values here. Let's do -2, 0, 1, and 2. If I plug in a -2, 2 to the -2, for those that like to see that, says, hey, it's not happy, it's going to go to the bottom, and now it's happy. 2 to the 0 power is 1, 2 to the first power is 2, and 2 squared is 4. So this is going to be the ordered pairs that are associated with this basic parent function. Now let's look up above and see what we have. We know that with exponential functions, we have a horizontal asymptote that aligns with the x-axis, so y equals 0. But, and don't get that confused, remember with logarithms, we have the vertical asymptote that aligns with the y-axis, so just opposite for our exponential functions. So here we can see that we are going to do some shifts, right? We're going to shift things to the left 3, and we're also going to shift things down 1. So down 1 makes it look like this. I took that horizontal asymptote, and so I'm going to come off to the side and write HA. Instead of it being HA of y equals 0, it's going to be y equals -1. And now I'm going to shift what would be my origin to the left 3. So 1, 2, and 3. Next up, this negative sign, because it's directly in front, it's like a -1 times this quantity. What it does is anything that's directly in front of the function is going to be multiplied by the y value. So to my y values, I'm going to take it times -1. So I have negative, 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 and negative. And now I'm going to graph. From this point, I'm going to go left 1 and down 1/2. From this point, I'm going to go 0 and down 1. From this point, I'm going to go right 1 and down 2. 1, 2. From this point, I'm going to go right 2 and down 4. 1, 2, 1, 2, 3, and 4. And so this is what it looks like. Now I can plug this in and show you how this is correct. So first let me clear the calculator. So I've cleared the calculator, and I'm just demonstrating how this is in fact the correct answer. So I'm going to use that negative sign. Now you're going to have to be able to do this without the use of a calculator, but I'm just using this to show you as you work on this at home. Are you oops, I missed the -1. Give me 1 second. I missed the -1. Okay, now I want to see that this is in fact correct. So does my graph look similar to this? It does. But let's take a look at this. If I come over here, I can see these different points, right? So this is my origin, and we can see, for instance, from here I went here and dropped down 1. So I believe that -3, -2 should be on this graph. Let's check. Let's check our table. -3, -2 is on the graph. So I'm just verifying this looks good. Another one says 2 to the right and down 4. So from this point, 2 to the right, that'd be -1, and down 4 would be down to -5. So I believe that -1, -5 should be on this graph. We can see -1, -5. I'm feeling confident that I correctly sketched the graph of this function. Now, we need to first start by identifying what is the parent function. So the parent function, whether it's g of x or y equals 1/2 raised to the x. And then I'm going to come over here and I'm going to establish some input and output values. Now, I don't personally like working with fractions as much, so I'm going to choose to use -2. Now, you don't have to. You could have started with 0, 1, and 2 and still achieve the correct sketch of the graph. So I have 1/2 raised to the -2. What does that look like? Well, it'd be 1 to the -2 over 2 to the -2, and then they're not happy, so 1 would go to the bottom and 2 would go up top. We'd have 4 over 1, or 4. And I could plug in -1. Now 1/2 to the -1, it'd be 1 to the -1 over 2 to the -1. It wouldn't be happy, so it'd be 2 to the 1 over 1, so I'd get 2. Now 1/2 to the 0 is simply going to be 1, and if I plugged in a 1, I'd get 1/2. I think that's enough points. Let's go over here and look. So we can see a couple different things here. We need to consider that we have -1 times x. That's going to that's going to impact the x values when I sketch. And we remember that we start with, before we have any type of shifting here, we start with a horizontal asymptote on the x-axis, and now I'm shifting it up 2. So shifting this up 2, okay, I've taken care of that. If it helps you, feel free to cross it out. And now I need to take, remember, in this position, if we have anything in front of the x that has to be factored out, it's going to be multiplied by the x's. So each one of these is going to be multiplied by a negative. So negative times negative 2 is positive, a positive, 0 doesn't change, and a negative. All right, so here is my new origin. There is no horizontal shift. It's not like negative x plus 2, right? It's just negative x. So here's my origin. I'm going to go right 2 and up 4 from here. Right 2 and up 4. Then I'm going to go right 1 and up 2. I'm at 0, 1, and I'm at negative and a half. And again, just like I did last time, let's quickly just verify that what we've done looks correct. So in parentheses, I have 1/2 raised to the negative x plus 2. And looks like this. We can see my graph. Yeah, it looks pretty similar, but let's check here on some of these points. So I believe that 0, 3 should be on the graph. It is. And I believe that 1, 4 should be on the graph. It is. And I believe that 2, 6, and it is. Verified. Let's go on now to number 3. Now, I get to be a little lazy here because I noticed that we have the exact same parent function, which is y equals 1/2 raised to x that I had in the previous problem. So I remember that this was negative 2, negative 1, oops, sorry, negative 1, 0, and 1. Okay, so I already established that from the previous question. Now we can look up above, and let me rewrite this. We have f of x, or y, equals negative times 1/2. Now I need to factor out that negative sign, and this is what I'd be left with when I factor it out. Negative x minus 3. So what am I doing here? And oh my goodness, I can see we have no graph. I'll need to input that in for next year. So the first thing is that I can see that I'm going to shift down the horizontal asymptote 1. Taking care of that. Next, this would be where my new origin is, but we need to shift it to the left 3. 1, 2, 3. So here's my new origin. I've taken care of this and this. Now, any negative sign that's out front, or in fact, any value that's factored in front of the x is going to impact the x's. So each one of these is going to be multiplied by this negative. That means it's positive and negative, because times negative 1 times negative 1 times negative 1 doesn't change anything, and times negative 1. The negative sign, or anything out front of the function, of the parent function, gets multiplied by the y's. So times negative, times negative, times negative, and times negative. Now from here, I'm going to go 2 to the right and down 4. 2 to the right and down 4. 1, 2, 3, 4. So 2 to the right and down 4. Then 1 to the right and down 2. 1 to the right and down 2. 0, negative 1, and negative 1, and negative 1/2. Let's take a look to make sure that this is correct. I'm going to go ahead and I'm going to clear the graph like I've done. And now I'm going to plug this in, taking time to plug it in correctly using those parentheses. And up top we have negative x minus 3, bring it back down, minus 1. So here's our graph. Will look similar to what I have over here. And now let's check a few of these points. So I believe here we would have left 3 and down 2. Let's check. Left 3, down 2. Or left 2, so negative 2, and it looks like 1, 2, 3. And so it would be negative 2. Let's see if I'm looking at this correctly. I was supposed to, let me go back here. I was supposed to go 2 to the right. Okay, so that's negative 1, and then down 4. Okay, so I should look at negative 1, negative 5. We can see negative 1, negative 5. I'm feeling confident with my answer. Let's flip to the back side. Algebraically determine the y-intercept of the function. When we determine the y-intercept of the function, x is always going to be equal to 0. Okay, so I'm going to write down y equals negative 3. Now when I plug in 0, 0 plus 4 is 4 minus 2. Okay, so this is not a negative exponent. Sometimes students say, well, it's not happy, put it to the bottom. That's not the case. This is like a negative 1 times 3 to the 4th. So 3 to the 4th is 81, and then if I take 81 times the negative sign up front, we get negative 81 minus 2. I believe that the y-intercept occurs at negative 83, or 0 and negative 83. Is there a way to check? There sure is. So let me plug in this equation. Negative 3 raised to the x plus 4, bring it down, back down, minus 2. And when we check here and we go to 0, we can see 0 is associated with negative 83. Let's go ahead and let's go on to part B. Again, we're going to substitute in a 0 in for x. So y equals 2/3. Now 0 minus 3 is negative 3. That's going to apply to both the numerator and the denominator. That makes the 2 unhappy because of the negative exponent. It comes to the bottom. 3 unhappy, it goes to the top. 3 to the 3rd is 27, and 2 to the 3rd is 8. Why? 3 times 3 times 3, and 2 times 2 times 2. Now, how you want to do this is up to you. You can find the common denominator, or you may want to use the butterfly method. Butterfly method always starts in the top right and diagonal down. 27 times 1 is 27. In this case, we drop in a plus sign. And then 1 times 8 is 8. On the bottom, we multiply it to get 8. All right, 27 plus 8 is going to be 35 over 8. This is what I believe the y-intercept is, but let's check. So I'm clearing it. We have 2/3 raised to the x minus 3, checking my work here, and let's check and see. So it has it at 4.375. Well, let's check. Is 4.375 equivalent to this? Let's check and see. And it is. I feel confident with this answer. You will have to do this by hand on your exam. Let's look up here. Again, we are replacing x with 0 to identify the y-intercept algebraically. Okay, here we go. We have 0 minus 1 is negative 1, and this looks similar to the last example we just did. Now I'm going to distribute that to get 4 to the negative 1 over 3 to the negative 1. The 3 isn't happy, it goes to the top. The 4 isn't happy, it goes to the bottom. And you can choose to use the butterfly method or find that common denominator another way. Always start in the top left-hand corner. 3 times 1 is 3. Drop down the negative sign. And 4 times 5 is 20. The order you do it in matters. What I mean by that is you have to start in the top left and go downwards. Then we drop down, and then we go second and go to the top right and come back. And then 4 times 1 is 4. So I believe that we have a y-intercept equivalent to 17 over 4. In fact, negative 17 over 4. Let's get an idea what that looks like as a decimal. So I believe negative 4.25. Let's check and see. So I come up here. I have 4/3 raised to the x minus 1. Subtract 5. And let's check. And we can see, yes, we do have negative 4.25. We're going on to our last set from this walk to learn for the first lesson, and evaluate the following using a calculator. Okay, so remember you do have a calculator that's located on our Google Teams page, and you can see the icon for it. So E, where do I find E? It's the blue key, and then straight down you're going to find it right here. It shares the key with the ln, and we're going to raise it to the negative pi symbol. Oops, looks like I made a mistake there. Let's try this again. Negative pi. Oh, I see what I'm doing wrong. Pi is blue, so I hit blue first. And then it says round to the nearest thousand. So this is approximately 0.043 when rounded 3 places past. Now we're going to go pi, and we're going to raise it to the negative 2. And we have approximately 0.101. And finally, how do we do cube roots? That's what this is. This is different than a square root. It's a cube root. Well, if you hit math, we're going to go down to the 4th option. And we already have a cube there, and then I have 5e. Whoops, and I have to do e to the first. Excuse me. How do you know it's to the first when you don't see an exponent to the first? Let's go do this once again. So math all the way down, and we have 5e to the first, and we have approximately 2.386.